All right, I've been trying to understand for the longest of time how there's a time dilation with someone traveling time at the speed of light and then returning back 25 years later, although it only took like maybe a year to them. So I came up with my own theory that's called spring theory. That's right, spring theory. Sounds like string theory, but it's spring theory because it's the only thing that makes sense to me, and this is how it goes.
We all know that space is bent, like they say. So let me draw a sine wave. Okay, that's your sine wave. So space is bent, curved, or however you want to look at it. And this is your normal place and time as you're traveling down this curve or this bend. Well, the faster you go, the more you start to separate yourself from that band of original time. It's like a time point of origin. So you start to separate yourself. So as you already see, to get to the other side, just because of the arc alone on the inside, it's going to take time. But then you figure, well, that's halfway there. Because at some point when you get to the crest, do you still travel at the same time? Like, where else do you go the faster you travel? And basically, it's within the loop. And what makes this possible is not a sine wave, but a sine wave of another sense. Here, I got an example. A spring. It looks like a sine wave, but it's actually a spring. And when you travel at the speed of light, you basically travel down the middle of that spring. The faster you go, the more tight of an arc that you basically conform to, which brings you closer to the middle. So it's almost like, even though you're inside the spring, there's a line that connects you to your time point of origin. So when you slow down, let's say, you go right to that line on the spring. Now, if you can picture a line with, let's say you're the dot traveling down the spring, and you have a line based line tied to the spring coil. So with a little bit of movement that you make, there's a lot of movement around the band. You see? So the further you travel on the inside of the spring, which is the speed of light, let's just say if you could compare it to moving an inch. Well, you may only move an inch on the inside, but the rest, your time point of origin, had to swing around a whole half a band loop, which is time, just to basically match your position, if you can understand that. So that's basically how it works. And as you slow down, you basically have this spring, and you start to, in turn, travel closer to the outer edges of the coil, which is the time point of origin. So, but once you get to the middle, what I think what happens is, this is what happens when you actually get to the speed of light. At that point, you are allowed to, let's see if I can do this by hand. Once you reach that speed, you are allowed to compress space. Now, you'll still be traveling through time, but the minute you break the speed of light, those bands or those coils become compressed. Now, although it may be still some time involved, it's on such an insignificant scale that it doesn't even begin to register on in the normal sense of time. It's within a blink of an eye, within a blink of an eye, within a blink of an eye, within a blink of an eye. So that's my theory on time travel. I call it spring theory. Have a go at it.